there, my dear students. Are you all feeling great today? That's good to hear. To those of you who don't know me yet, I am Teacher Daryl, and I am here for another scientific learning and discovery. Join me as we explore the amazing world of science. For this quarter's branch of science, we will be focusing on chemistry. Before we proceed in today's exciting lesson, allow me first to lay down our virtual classroom rules. For the first one, create or be on a comfortable study space to ensure an optimal learning experience. For the second rule, set aside any object that could distract you from your virtual class. Third rule, always be respectful towards your teachers and your classmates. Remember class, I will not tolerate any form of bullying in this classroom. And for the last one, enjoy the whole learning experience. For some health concerns, since you will be in front of your screen for quite a few minutes, you can always pause the video for a moment to rest your eyes and resume afterwards. In case you feel some back pains for sitting too long, always make sure to do some stretches. Remember class, your health should be your topmost priority. I think that's it. Shall we proceed now to our lesson? Alright, let's go!
Okay, so let's start our lesson through a review activity. In your previous years of learning, you have learned about physical and chemical changes. Am I right? Okay, that's good to hear. So this activity is called I am changing. I will be flashing some photos which you will identify whether each exemplifies a physical or a chemical change. Are you ready? I think you are, so let's get started. Starting off with the first photo. Melting of ice. Is melting of ice an example of a physical or chemical change? Your answer is? That is right, it is an example of a physical change. You see class, when ice melts, it only changes its form but not its chemical identity. Thus, melting of ice is an example of a physical change. For the next photo, we have burning of wood. So is burning of wood an example of a physical or a chemical change? What is your answer? You are right again because the answer is chemical change. You see class, when wood burns, it undergoes a process called chemical reaction. And when chemical reaction occurs, this results to a new product or a substance. Okay, that is why burning of wood is an example of a chemical change, from wood to ashes. Okay, so let's have our third photo, which is mixture of vinegar and baking soda. So what is the answer? The answer here is still chemical change. Very good. Okay, for the next photo we have melting of ice cream. So is melting of ice cream an example of a physical or chemical change? The answer is very good. The answer is physical change because it only changes its form, not its chemical identity. And for the last one, we have ripening of mango. So is ripening of mango an example of a physical or a chemical change? The answer is very good. The answer is chemical change. Ripening process involves a series of metabolic activities, and these metabolic activities causes chemical changes. Very good.
Well done, my dear students. I am pleased to know that you still remember these concepts, especially the idea of chemical changes. As already discussed before, chemical changes happen because chemical reactions take place. Particles of reactants collide, resulting to a chemical reaction. To further engage you in this lesson, let's move on to our next activity. Since we have already spoke about collision, let's have a look at this photo. Do you know what Pinoy parlor game is exhibited on screen? That is right. It is called Basagang Palayok, or also known as the Pukpok Palayok. Now class, here are my questions, starting off with the first one. What do you exactly do to get the prizes inside the palayok? Precisely. You are first blindfolded, asked to spin a few times, and that's when you will hit the palayok with enough energy in order for the collision of the bat and the palayok to happen. And such collision will result to the breakage of the pot, exposing the prizes inside the palayok. Now here's another question. Is it enough for the bat and the palayok to collide regardless of the energy exerted on the palayok? No, very good. Because enough energy must be exerted during the collision in order to get the prizes inside. Because a mere contact between the bat and the palayok will not result to a breakage. Now, in relation to this, just like how the Pukpok Palayok is played, in order for a chemical reaction to take place, there must be a collision of particles, and that these particles must be in correct orientation and must meet the minimum amount of energy in order for chemical reactions to take place. These, class, are the assumptions of the collision theory.
At the end of this lesson, through interactive activities, you are expected to explain the collision theory. Second, identify the factors affecting the rates of chemical reactions. And explain how the factors affecting chemical reactions are applied in real life.
Do you now know how chemical reactions take place? Very good. It is through the collision of particles or reactants that such reactions take place. Now, to further deepen our understanding about chemical reactions, let's have a series of experiments. Are you ready? Then come on, let's explore the beauty of science.
This activity is called Lights, Camera, Reaction. So the class will be grouped into 5. Group 1 and 2 will perform experiment 1, Group 3 and 4 will perform experiment 2, and Group 5 will perform experiment 3. Guide questions will be given for each experiment. The groups will submit their answers via Messenger or Google Drive. For experiment 1, you will be needing 2 effervescent tablets, 2 identical glasses, hot and cold water, and 2 thermometers. Here's what you need to do. Get 2 identical containers and fill the first container with hot water and the other one with cold water. Second, get the temperature readings of the 2 containers containing water of different temperatures. After that, simultaneously drop each of the tablets in each container and observe the rate of dissolution of the tablet in each container. Once you're finished with the experiment, you will be answering these guide questions. First, is there any noticeable difference between hot water and cold water? Second, which has a faster reaction, hot or cold water? And then lastly, what is the effect of temperature on the reaction rate? A QR code is also provided if you want to watch the sample video for this experiment. For experiment 2, you will be needing 2 effervescent tablets, one is pulverized and one is not, 2 identical glasses, and tap water. First, get 2 identical containers and fill these with water. Make sure that the water levels for both containers are the same. Second, put the pulverized effervescent in the tablet in each container at the same time. Once dropped, observe what happens. Here are the guide questions for this experiment. Which dissolves faster, the pulverized effervescent or the tablet one? Second, what could be the possible reason on the difference of the dissolving rate between the powdered effervescent and the tablet one? And why is this so? A QR code is also provided if you want to watch the sample video for experiment number 2. Now for experiment number 3, you will be needing 2 glass containers, yeast, hydrogen peroxide, and spoon. First, put 2 tablespoons of hydrogen peroxide in both containers. After that, put a tablespoon of yeast in one of the containers. After doing so, observe what happens. When you finish experiment number 3, you will be answering these guide questions. For number 1, what happened when the yeast was mixed with the hydrogen peroxide? Second, what significant role did the yeast play in the chemical reaction that happened in the experiment? Now, if you want to watch the sample video for this experiment, you may scan the QR code flashed on your screen. If you have any questions about the experiment, you may message me via Messenger or other means. Enjoy the activity and have fun!
Did you enjoy the series of experiments that we just performed? I am very pleased that you did. And now, let's see what these experiments have something to do with our lesson for today. Grab a pen and notebook and watch and listen attentively as we unfold the reasons why some chemical reactions are faster than others.
This segment is called I Deserve an Explanation. As we have mentioned earlier, in order for chemical reactions to take place, two things must be considered. This is in accordance to the assumptions of the collision theory. According to this theory, effective collisions only occur when, first, colliding molecules reach the minimum energy required to start a chemical reaction. Class, bear in mind that just because particles are colliding, it doesn't necessarily mean that a chemical reaction will happen. The activation energy must be reached first. Just like the game of Pokpok Palayok, it's not enough to create a contact between the bat and the palayok alone. If you happen to smash the palayok with a weak force, this will not break the pot. And enough force must be exerted to break it, releasing the prizes inside of it. For the next assumption, reactants must be in correct orientation when they collide. Now, why is this so? Because this will determine the frequency of collision within molecules. A correct angle of orientation of particles will create a favorable chance for the molecules to collide more frequently. Now, why are there requirements for chemical reactions to occur? Why would we still need to put into consideration the activation energy and the angle of orientation of molecules? Why not just make it easy for every chemical reactions to happen? The answer? Simple. Because if every contact of particles with other particles leads to a chemical reaction, then that would be a problem. If chemical reactions happen so easily, the foods that we eat or make will immediately get spoiled. The fruit that we pick will immediately ripen and get rotten. The roof of our homes will immediately rust if no threshold will be set for these particles or substances. These are just some of the reasons why particles must need to reach a minimum amount of energy and must be in correct orientation in order for chemical reactions to happen.
And now, let's explain the experiments that we performed moments ago. For the first experiment, you may have noticed that the rate of reaction between the two effervescent tablets were different when they were both submerged to a hot and cold water. Now class, what factor may have affected the rate of chemical reaction? Very good, it's the temperature. You may have observed that the hot water had easily dissolved the effervescent as compared to the cold one. This implies that the higher the temperature, the faster the reaction, and the lower the temperature, the slower the reaction. This is because when temperature is high, particles move faster, which results to more collisions, allowing chemical reactions to take place at a faster rate. Let's now explain the second experiment. If you remember, we had pulverized one of the two effervescent tablets. And when both the pulverized and the whole tablet were dropped in the water at the same time, the pulverized effervescent dissolved faster as compared to the tablet 1. Now here's the question test. What factor may have affected the tablet's and water's rate of reaction? Exactly, it is the surface area. The larger the surface area, the faster the chemical reaction. Since we have pulverized one of the tablets, we have allowed its particles to be more exposed to another reactant, which in the case of the experiment is the water. Because of this, we have allowed a greater chance for the particles to collide, thus increasing the rate of reaction. Let's now explain the third experiment where we used hydrogen peroxide and yeast. As I have mentioned in the experiment 3, when hydrogen peroxide is exposed to air, it already starts disintegrating, releasing oxygen into the air. This process of disintegration is not visible to the naked eye because of the slow disintegration. Now, when we added the yeast to one of the glasses containing hydrogen peroxide, you have observed that it has formed bubbles. The hydrogen peroxide with the yeast disintegrated faster than the other glass of hydrogen peroxide. The yeast glass increased the rate of reaction of the hydrogen peroxide, releasing oxygen faster, thus the formation of bubbles. The yeast is an example of a catalyst. So what is a catalyst? A catalyst gas is a substance that can be added to a reaction to increase the speed or rate of a reaction without getting consumed in the process. Aside from temperature, surface area, and the presence of a catalyst, another factor affecting the rate of reaction is the concentration of reactants. Now, what does the concentration of reactants have something to do with the rate of chemical reaction? You see, class, at a higher concentration, there are more particles in the same amount of space. This means that the particles are more likely to collide and therefore more likely to react. Take a look at this example. You can see there that there are two beakers containing different amount of concentration of dyes, and a white cloth is half soaked in each beaker. The dye solution in the left beaker is more concentrated than the beaker in the right, because increasing the concentration of dye increases the rate of color change in the material. Now you know the 4 different factors affecting the rate of chemical reactions. But do you know how these factors affecting the rate of reactions are applied in real life? Let's take a look at the photos which I will be showing in the next slides, and tell me which factor applies in each.
Let's start with the first image. So as you can see there, it's a refrigerator wherein there are lots of foods inside of it. Now here's the question. What factor plays an important role in slowing down food from spoilage by putting them inside a refrigerator? What is your answer? Very good. It is the temperature. This is the reason why we put our leftover foods and some of our perishable foods inside the refrigerator, because the temperature inside the ref or refrigerator is low. Okay, so when the temperature is low, the movement of molecules is also slow. Thus, the collisions will also be slow, resulting to a slower chemical reaction. And when the temperature is high, the movement of molecules is also very fast or very rapid. This results to a faster collision and a faster chemical reaction. Now for the next example, we have 2 photos here. We have pork belly on the left side, which is relatively bigger than the barbecues on the right side. Now here are my questions. Between the bigger and the smaller cuts of meats, which will cook faster when you grill them? What is your answer? Very good. It is the barbecue, okay? Because it is relatively smaller in size. Now, what factor plays a role in the rate of cooking of the meat? What is it? Very good. It is the surface area. Since barbecues are cut into smaller portions, this means that its surface area is larger. And when the surface area is larger, the rate of cooking is faster. Alright, for the next image, in speeding up the ripening process of bananas, calcium carbide is kept among the bananas where in contact with moisture produces acetylene gas which helps in speeding up the ripening process. What factor plays a role in speeding up the ripening of bananas? What is your answer? Good job! It is the calcium carbide. The presence of calcium carbide acted as the catalyst in speeding up the ripening process of bananas. When this compound is in contact with water, acetylene gas is produced which speeds up the ripening process of fruits like bananas. And for the last image, in washing a stained shirt, when more amount of detergent is added to the water where the shirt is soaked in, the removal of stain is easier. In this example, what factor plays an important role in speeding up the removal of the stain? What is your answer? Very good. It is the concentration of reactants. When we add more detergent powder, we are increasing its concentration in the water. And this increase in concentration is the reason why the stain is easier to remove. That's good. Very good, class. Now you know the concept of the collision theory, the factors affecting the rate of chemical reaction, and how these factors are applied in real life. Now let's see if you really learned something. Get a clean sheet of paper and a ball pen and write the letter of the correct answer as we go along each item. You may also pause the video if you think you need more time to answer. You may also answer orally if you want to. Are you ready? Let's begin, starting off with the first question. Which of the following statements best describes collision theory? A. Atoms or molecules must collide with sufficient amount of energy in order to react. Letter B. Catalysts can be recovered unchanged at the end of the reaction process. Letter C. Increasing the rate of a reactant increases the rate of reaction. Or letter D. Smaller pieces have greater surface area, thus providing much greater contact among the reactants and effecting more collisions. So what is the answer? The answer is very good. Letter A. Atoms or molecules must collide with sufficient amount of energy in order to react. And that sufficient amount of energy that needs to be met is called the activation energy. For question number 2, how will crushing a solid into a powder increase reaction rate? Is it letter A, the activation energy barrier will be lowered? Letter B, the concentration of particles will improve? Letter C, the particles will collide with more energy? Or is it letter D, the powdered form has more surface area? So what is the answer? That's right. The answer is letter D. The powdered form has more surface area. Because when solids are crushed into smaller particles, the surface area is greater. Thus, more chances for the molecules of the reactant to react to other reactants, which in return speeds up the rate of chemical reaction. For question number 3, Filipino farmers use different natural ripening agents such as the use of kalburo, leaves of cacahuate and acacia leaves. This practice intends to address the need for the availability of fruits all the time. Now, what factor affecting the rate of reactions influence this situation? Is it letter A, the presence of a catalyst? Letter B, concentration of reactants? Letter C, surface area? Or letter D, temperature? So what is the answer? Very good. For this question, the answer is letter A, the presence of a catalyst. Farmers use the kalburo in speeding up the ripening process of fruits. The kalburo class is an example of a catalyst. Now for question number 4, perishable goods that are not properly stored show signs of spoilage in less than a day. Now which of the following is not a possible cause of this spoilage? Letter A, the amount of goods. Letter B, change in temperature. Letter C, oxygen in air. Or letter D, the presence of microorganisms. So what is the answer? That is right. The answer is letter A, amount of goods, because the presence of oxygen in air, the change in temperature, and the presence of microorganisms may all contribute in speeding up the spoilage of food, but not the amount of goods. For question number 5, perishable goods that are not properly stored show signs of spoilage in less than a day. Which of the following will help in lengthening the shelf life of these goods? Is it letter A, place the goods in a warm place? Letter B, add more goods? Letter C, place the goods inside the refrigerator? Or letter D, just consume the goods. So what is the answer for this question? Very good. The answer is letter C. Place the goods inside the refrigerator. This is the reason why whenever we have leftovers or food that easily spoils, we place them inside the ref, because refs have relatively lower temperature, thus prolonging the shelf life of our perishable goods. For items 6 to 10, you will identify whether each statement is true or false. For number 6, frequent collisions among particles of reactants will lead to a faster rate of reaction. This statement is true or false? Very good, it is true. For number 7, a presence of an inhibitor is needed in order to increase the rate or speed of a chemical reaction. This statement is true or false? Very good, it is false, because it is a catalyst, not an inhibitor, that speeds up the rate of chemical reaction. An inhibitor, on the other hand, stops or slows down the rate of reaction. For number 8, in order for chemical reactions to be successful, it is acceptable not to reach the activation energy required, as long as the orientation of the particles involved in the reaction is correct. So for this statement, is it true or false? Very good, it is still false. Because in accordance to the collision theory, activation energy must be met and particles of reactants must be in correct orientation in order for a chemical reaction to take place or to be successful. For statement number 9, the factor that plays a role in processing milk into yogurt is the presence of a catalyst. Is this statement true or false? What is the answer? Very good, it is true. The presence of bacteria processes the milk, turning it into a yogurt. And for number 10, using bleach to remove stains from white clothes, the higher the concentration of bleach, the more effective it is in removing stains. So for this statement, the answer is very good. It is, once again, true. Okay, so did you get all the items correctly? Well done, class. That is only a proof that you really understand our lesson for today.
We are now down to our last segment, which is the assignment. So with the 4 factors affecting the rate of reaction, choose one factor and do your own experiment in explaining how your chosen factor affects the rate of chemical reactions. Upload your experiment video using this Google Drive link. And that's it for today. I hope you have learned something significant in this lesson. Once again, I am Sir Daryl, reminding all of you to stay inquisitive and amazing. Until next time, bye!